So today let us continue the exercise 1.2, differentiating the following with respect to x, tan inverse of log of x. Now here there is a composite function, so we have to think of chain rule. Okay, so y is equal to tan inverse of log x. As there is no any function name is given, so we have given the name y is equal to tan inverse of log x. So we will differentiate this with respect to x, but before differentiating I will tell you how to differentiate tan inverse of log x. We will treat it as a tan inverse of f of x, and we will use that formula that already I have given in the previous lecture. Y is equal to tan inverse of log of x is d by dx of tan inverse of f of x. Tan inverse of f of x is 1 upon 1 plus f of x square into f dash of x. So d by dx of log of x. Its derivative is 1 upon x. So what is the derivative? Dy by dx is 1 upon x times 1 plus log of x square. The next example, cosec inverse of e raised to minus x. Again, same cosec inverse of f of x. Its derivative is minus 1 upon e raised to minus x square root of e raised to minus x square minus 1 into f dash of x is d by dx of e raised to minus x. Cosec inverse of f of x is minus 1 upon f of x square root f of x square minus 1 f dash of x. Simplify it. Now derivative of e raised to f of x is e raised to f of x into f dash of x. So f dash of x means derivative of minus x is minus 1. So minus 1 and this minus 1 now we will cancel to each other, and the function become plus, and this e raised to minus x and this e raised to minus x is again cancel, and what you get 1 upon square root of e raised to minus 2x minus 1. Cot inverse of x cube. So y is equal to cot inverse of x cube. Differentiate with respect to x. What you get? Cot inverse of f of x is minus 1 upon 1 plus f of x square into d by dx of f of x. So d by dx of f of x means d by dx of x cube. Its derivative is 3x square, because derivative of x raised to n is n times x raised to n minus 1. So dy by dx is equal to minus 3 times x square 1 plus x cube its square. So now different cot inverse of 4 raised to x. This function and these functions are derivatives are same, but here they have taken x cube, and now here there is 4 raised to x. That means the function a raised to x. So again cot inverse of f of x is minus 1 upon 1 plus f of x square into f dash of x, and d by dx of a raised to x is a raised to x log a. Using that formula you get minus 4 raised to x log 4 upon 1 plus 4 raised to 2x. Next example, tan inverse of root x. So tan inverse of f of x is 1 upon 1 plus f of x square into f dash of x. Root x square is x, and d by dx of root x derivative is 1 upon 2 root x. 1 upon 2 root x. Just simplify, rewrite it. 1 upon 2 square root of x in bracket 1 plus x. Now differentiating the following with respect to x. Sin inverse in bracket square root of 1 plus x square upon 2. So let y is equal to sin inverse in bracket root 1 plus x square upon 2. Now differentiating this, sin inverse of f of x. Treat this function as sin inverse of f of x is given by 1 upon root 1 minus f of x square into f dash of x. So now d by dx of root f of x, its derivative is 1 upon 2 root f of x into f dash of x. So 1 upon 2 is constant, derivative of 1 is 0, and derivative of x square is 2x. Now in next step, this root 2 will be at the denominator. So we'll go to the numerator. Root 2 will cancel to each other, and the square root of 1 minus x square and square root 1 plus x square. We will combine these two in one square root. A minus b, a plus b is a minus b square, a square minus b square. So 1 square minus x square, its square, x raised to 4. So this is the derivative of the given function. Now cos inverse in bracket 1 minus x square. Let y is equal to cos inverse of 1 minus x square. Differentiating with respect to x. Now we will treat this function as cos inverse of f of x. Is minus 1 upon 1 minus f of, square root of 1 minus f of x square into d by dx of f of x. D by dx of f of x means d by dx of 1 minus x square. Derivative of 1 minus derivative of x square. The derivative of 1 is 0 and derivative of x square is 2x. Simplify this minus and this minus. You get plus 2x upon root 2x square minus x raised to 4. We can take x common from this x square common, so that our when it comes out the square root, it remains x. So we will cancel this x, and dy by dx is 2 upon square root 2 minus x square. The next example, y is equal to sine inverse of x raised to 3 by 2. So y is equal to sine inverse of x raised to 3 by 2. So differentiating with respect to x, we get dy by dx is equal to 1 upon square root of 1 minus x raised to 3 by 2 raised to 2 into dy by dx of x raised to. So sine inverse of f of x, its derivative is given by 1 upon root 1 minus f of x square into f dash of x. Using that formula, you will get 1 upon root 1 minus x cube into 3 by 2 x raised to 3 by 2 minus 1 is 1 upon 2. And x raised to 1 upon 2 means root x. So 3 by 2 into root x upon 1 minus x cube. We can take this term in 1 square root. So 3 by 2 in bracket in square root x upon 1 minus x cube is the derivative of the given function. Differentiate the following with respect to x. Cos cube of cos inverse of x cube. Now here there is a composition of three different functions: cos, then cos inverse, and x cube. So y is equal to cos cube of cos inverse of x cube. We can write this function as y is equal to cos of cos inverse of x cube bracket raised to 3. So this is, I will differentiating with respect to x. So now here cos of cos inverse, using the property cos of cos inverse of x is x. Okay, we get x cube bracket raised to 3. That means y is equal to x raised to 9. So differentiate with respect to x, we get d by dx of x raised to 9 is 9x raised to 8. By first, if we see this example, it looks very complicated, but after simplifying we get a simple function whose derivative we can easily find out. The next example is sine raised to 4 in bracket sine inverse of root x, same as that of the previous one. We will take whole bracket raised to 4, and again we will the properties sine of sine inverse of x is x. So root of x raised to 4 is x square. Differentiate with respect to x, we will get d by dx of x square is 2x. The next example is cot of e raised to x square. Now here also the same property, cot inverse of cot x is x. If after using that property, I will write y as e raised to x square. Now after differentiating this function with respect to x, we have to use the formula y is equal to e raised to f of x. Derivative of e raised to f of x is e raised to f of x into f dash of x. So e raised to f of x into d by dx of f of x. F of x is x square, so d by dx of x square is 2x. So what is the derivative? 2x e raised to x square. The next example is cosec inverse of 1 upon cos 5 raised to x. Now we have cosec inverse of 1 upon cos raised to 5x, cos of 5 raised to x. 1 upon cos can be written as sec. So cosec inverse of sec 5 raised to x. Again, we can write this cosec in terms of this sec in terms of cosec as cosec 90 minus theta. Cosec 90 minus theta is sine theta. So Sin 90 minus theta is cos theta, and cos 90 minus theta is sin theta. So after using that allied angle formula, this cosec and cosec will cancel, and we get y is equal to pi by 2 minus 5 raised to x. We will differentiate this function with respect to x. Derivative of pi by 2 is 0, and d by dx of 5 raised to x is 5 raised to x log 5. So minus 5 raised to x log 5 is the answer. Moving further, third example from the seventh type, cos inverse of square root of 1 plus cos x upon 2. Now here 1 plus cos 2 theta is 2 cos square theta. So here is not 2 theta, here is only theta. So 1 plus cos x is, we have to use the half angle formula, 2 cos square theta by 2, 2 cos square x by 2. So this 2 will cancel to each other, and 2 only remain cos square x by 2. This square root and this square will cancel to each other. We get cos inverse of cos x by 2. Again, we use the property cos inverse of x is x, or cos inverse of cos x is x. So we cancel each other and we get x by 2. And different derivative of this x by 2 is only half. Next example, cos inverse of square root of 1 minus cos of x square upon 2. Again the same formula. Here 1 plus cos 2 theta is 2 cos square theta, and 2 cos square theta, and here is 1 minus cos 2 theta is 2 sin square theta. So 1 minus cos theta is 2 sin square theta by 2. So x square upon 2. Again 2 cancel, square root and this square will cancel. What you get? Cos inverse of sin x square by 2. And this here I will use the allied angle formula, cos 90 minus theta is sin theta, cos of 90 minus theta. So these 2 cancel to each other and you get pi by 2 minus x square by 2. Then I will differentiate this with respect to x. Derivative of pi by 2 is 0, and derivative of x square upon 2 is 2x, because 1 upon 2 is constant, it is outside, and derivative of x square is 2x. So dy by dx is minus 1 upon 2 times 2x minus x. The next example is tan inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. Now here this bracket, we have to convert it into the one of the tan formula, tan a plus b or tan a minus b, because the outside is tan inverse. How to write it? I will write these, or I will simplify it using 1 can be written as tan pi by 4. Here is also 1 tan pi by 4, and there is also 1 tan pi by 4. Tan pi by 4 minus tan x by 2 upon 1 plus tan pi by 4 tan x by 2. This is tan A minus tan B upon 1 plus tan A into tan B. So I can write this expression as tan of pi by 4 minus x by 2. So these 2 will cancel each other and you get pi by 4 minus x by 2. Differentiate this function with respect to x. The derivative of pi by 4 plus minus derivative of x by 2. So we get minus 1 upon 2. Now cosec inverse of 1 upon 4 cos cube 2x minus 3 cos of 2x. So again the cosec inverse can be written in terms of cos, because this is the triple angle formula. Cos 3 theta is 4 cos cube theta minus 3 cos theta. Using that formula, you will get 1 upon cos 3 times 2x. In that number 6x. Taking the reciprocal, you get sec 6x. And then this sec theta can be written as cosec 90 minus theta. Then using the property of inverse trigonometric function, y is pi by 2 minus 6x, differentiate with respect to x. Derivative of pi by 2 is 0, and derivative of 6x is 6. So the derivative of the given large function we got is as minus 6 only. Now tan inverse of 1 plus cos x by 3 upon sin x by 3. Now here we have to use this cos 1 plus cos theta is 2 cos square theta by 2, and this is sine. We have one formula of sine 2 theta is 2 sine theta cos theta, but here is only sine theta, not 2 theta, so we have to use the half angle formula. Sine theta is equal to 2 sine theta by 2 cos theta by 2, so 2 sine x upon 6 plus into cos x upon 6. So y is equal to tan inverse of, in bracket, this 1 cos will cancel to this cos x by 6. This 2 will also cancel and you get quat x by 6. Okay, and then we will use the allied angle formula and convert this quat into tan of pi by 2 minus theta is cot theta. So this again use the property tan inverse of tan is only the x. So we get y is equal to pi by 2 minus x by 6, and differentiate with respect to x, we get d by dx of pi by 2 minus d by dx of x by 6. It is 0 minus 1 upon 6 is minus 1 upon 6 is the derivative of the given function. Again, today we will end up our session at this stage only. We will continue our session, the exercise 1.2 in our